record the program. And then I'm going to go ahead and share my screen. Let's share this first here. I think that's the right one. Okay, you guys seeing that?
Yeah.
Yeah, the blackboard, right?
Yep. So this is this week's, if you go in, it's lit up here, lesson 4. Okay. So it is available. There's some things on repetition here. Okay. Don't pay any attention to, he's got them all in methods and that. Just kind of skip over that. And again, just glance through these. Okay. As far as our assignments go, there's 3 of them. We're going to do this elementary math one tonight, or at least start it. Craps, I can, okay. So, any of you guys know how to play craps? This is always a big question.
I can't do, but I have heard of it.
Okay. Okay.
You explained
So,
it last semester, yeah. I
yeah.
still don't know.
Okay, so here's the deal. Now you might want to write this down, okay? So you have 2 dice, okay? You roll the dice, the 2 dice. Okay, so they're going to be randoms, right? 1 to 6, okay? And if you roll a 7 or an 11 on the first roll, has to be on the first roll, you win the game. Okay. If, however, you roll a 2, a 3, or a 12 on the first roll, you lose. Okay. So 7, 11, you win. What did I say? 2, 3, and 12, you lose. That's called craps when you lose. If you roll any other number than that, okay, it's called your point. So if you roll a 4, 5, 6, 8, 9, 10 on the first roll, 4, 5, 6, 8, 9, 10, that's called your point. And once you have your point, you keep rolling until either you roll your point again and you win, or you roll a 7, at which point you lose. Okay, so I'll go over it again. 7, 11 on the first roll, you win. 2, 3, or 12 on the first roll, you crap out and lose. 4, 5, 6, 8, 9, 10 becomes a point, and you keep rolling until one of 2 things happens. If you roll that same number over again, you win. If you roll a 7 after the first roll, you roll a 7, you lose. After the first roll, the 2, 3, and 12 don't mean anything. You just keep rolling. Okay, because they can't be your point. You would have lost in the first round, right? The only ones that can ever be your point are 4, 5, 6, 8, 9, 10. So if I roll a 7 on the first roll, I win. If I roll an 11 on the first roll, I win. If I roll a 2 on the first roll, I lose. If I roll, and the game starts over. If I roll a 3, I lose, the game starts over. If I roll a 12, game's over, I lose. If I roll a 5 and then I roll an 11, nothing happens. If I roll the next roll, I roll a 2, nothing happens. If I roll an 8, nothing happens. If I roll a 5, I win, because then I rolled my point. Let's say that I roll an 8 first time. Second time I roll an 11, nothing happens. I roll a 7 on the next roll, I lose. So that's the game. Okay. That's basically how it works. So that's the game you're going to build for me. And I pretty much put it here and explained it to you. Now, again, what another thing you should be thinking of just for your future is that what is the most likely number to roll with a pair of dice? Oh, somebody guess.
7.
Damn, 7. Yeah. There's more combinations of 7 than any other one. So you're more likely, the odds are that you're going to roll a 7. So it's good on the first roll, right? You have the better odd on the first roll to roll that 7 and win. Okay. But the problem is after the first roll, what's the most likely thing you're going to roll? And if you roll a 7 after the first roll, you lose, right? And that's what happens. Okay. So you just have that in mind. The most unlikely ones to get are what? There's only 2 of them. The most unlikely numbers to roll. David, how about you?
2 and 12 or something.
Yeah, 2 and 12, right? There's only one combination for 2 and one combination for 12. Okay. So that's basically how it works. And it doesn't matter in real life if somebody has a point, like let's say they roll a 5 and a 3 for an 8. If you're at a casino and you roll, of course, if you roll 4 and 4, that's an 8. You can roll a 6 and a 2, that's an 8. And then, but let's just say you roll a 5 and a 3 and it's an 8. If you were in a casino and then you want to bet on that you'll roll another 5 and 3 exactly, you can do that. We're not worried about that though. Any way you roll an 8, okay? And I want you to, you just don't, you're going to roll 2 dice. So you need to show both dice, okay? So you're going to have 2 numbers showing, one for each die in the program. Don't just say, okay, I rolled a 12. No, you roll 2 6s for a total of 12. And then you either win or lose, depending. Well, on a 12, you'd always lose, or it wouldn't mean anything after the first roll. The distance traveled program isn't too hard. Okay. Except I want you to, I want you to print them out. Okay. After an hour, I went this far. After 2 hours, we went this far. 3 hours. So you should have a chart. If you can see my hands, you should have a chart going down the page, right? So if you drive for 8 hours, you should have 8 outputs. And you drove 30, X number of miles, et cetera, et cetera. Let's see what else I got, what it says there. Yeah. Oh, look at, I spelled decides, decised. Fix that. Right. Blah, 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 can be decided. Decided the size to quite. That's pretty close. There we go. That should be better. What if I drive for 2.5 hours though? You have to figure that out, right? I mean, because if I drive for if I'm doing 100 miles an hour and I drive for 2 hours and 2.5 hours, and I get out of the car after I'm going to be 50 miles away from the car, right? So you need to cut off. Oh, that sounds like that. What is that thing that have to figure out how to get that remainder and multiply it by the speed? Get a percentage or a fraction of an hour. Okay. And it has to, again, that isn't the hardest. Then you got to make sure it prints out the total distance. So you'd have hour 1, hour 2, and then 2.5 printed out in that case. Not too bad. It's not that terrible. So any questions on those? No? And like I said, we're going to work on this bottom one. Let me see if you guys see this when I go there. Do you see that now?
I
Yeah.
can see the string formatting.
Yeah. Okay. So somebody asked me about this the other day. I'm going to go ahead and let you guys do this. Okay. So like in this first one here, okay. Let's see if what this does when I hit run. Well, how do I, oh, there it is over here. Okay. So what happens here is you put, so they just declare John, for example. Then you set up your string in between your 2 quotation marks, and this becomes a placeholder. This is the same as Java almost. Okay. So here you see the %S. That means it's going to be a string that I'm going to put in there. And then just in Java, we use a comma instead of the %. After you're done with this, you type the %, and then what are you going to put in that space holder? And in this case, we're going to put somebody's name. And when I run it, you can see it says John there, right? Let's see. I don't know. I think I could change this actually. And I'll run it. And you can see there it prints hello, Doug. So if we move down one, in this one, we have John and his age, okay? Notice when we put that one between the 2 double quotes, that the first one is a placeholder for a string. The second one, a D, means it's going to be an integer. Okay. And then we're going to fill that in with name and age. So the first one is for name. Now these have to be in the right order. So name is going to go in the S, and their age is going to go in here. And if I run it, you can see John is 23 years old. And if John was 68, oops, and we can run that. And you can see John is 68 years old. Moving down here, formatted using S operator, my list. Let's see what happens on that. Let's see, don't do that one. I think that's good enough for now. I believe, let's see if I can do this one. 0.2F. And let's try this. Okay. So if you do this, I'm going to get a 2 decimal places for a floating point. So that isn't, it doesn't tell you that right here. But if you write that down, then you can. So let's say if it was money, I could put a $sign here and run it. Okay. So this is kind of, there's another new way to do it, but this one is easy. Okay. So for right now, I would go ahead and use this one. And then we'll look at later on, we'll go ahead and look at the one that uses braces around it. But for right now, and then especially like some of you, I think might be in my Java class too. This is the same way we format things in Java, almost exactly, except that we replace this percent sign with a comma there. All right. So take a look at that. And now this is fair game in our class.
So this is how you'd get rid of that space between the variable and the string.
Yeah, you could get rid of your spaces now.
Sweet.
Yep. So it'll just look nicer, right? Okay, somebody's got their mic on. That's cute.
Hey, Doug, before we start that, I had a quick question about last week about if loops or if statements.
Okay.
Sometimes it loops and sometimes it doesn't. Have you noticed that?
Well,
or
no, not if it's written right. It's impossible.
impossible for it to loop?
No, I
To
mean, what do
not
you
loop.
mean? It sometimes it loops and sometimes it doesn't. Of course it doesn't. If it's not set up right, it's not going to loop. Or if the sentinel is not correct, then it's not going to loop. You have to have all four parts of the loop or it's not going to work. And the sentinel has to.
Well, that's what I was curious about, because I have a program where an if statement, validates the input, and it actually loops around if you don't enter the correct thing. And I'm like, why would it do that? And then, anyways, it was just confusing.
Well, again, if you're checking for validation, it will keep looping until they put in something that is correct. If you have it set up that way.
If you have if input validation, if it's
Right.
not
Could I show
correct,
you what I'm talking about real quick?
Yeah, let's go ahead and take a look real quick. Hang on, let me stop sharing.
I'm probably full of it, but
no.
Let's see here. Let me full screen this. Alrighty. Okay, so I'm this one. Well, let me show you the one where it works. I have this if else set up right here, and somehow it loops around. So if you enter a negative, or if you enter 0, it loops. So I'm just flabbergasted by why it does, and I try to apply
you have a loop up here.
Where?
The loop that is. Do you wish to play again?
I mean, yeah, I have the loop to run the whole program again.
Right.
But I don't have any loops for this.
But I don't know what's wrong. I mean, I don't know what you're saying is wrong.
I see it. Is it that it's running into the elif statement, and then when it hits there, it just repeats?
Yeah, if it displays that and jumps back up here, even though there's no loop. And so I was like, wow, that's cool. So I tried to apply this to my other programs and it doesn't work at all.
Oh,
so just a weird thing. I don't know. Sure.
Look at 23.
Because your keep going is inside your loop, or needs to.
Can you bring me some, or wait, I can just get some?
Hey, you got your mic on. Keep going. Bring it out one tab.
Well,
left.
I mean,
Move
on this, I
left.
like the way it works.
Move it to the left.
Right.
Now run it.
I mean, but I want it to loop. I mean, that's a nice feature.
Well, it will.
But if okay, well then that proved that when keep going is in there, it loops again. So I'll put my keep going in like here. It's all right. Anyway, that actually answered my
It
question.
should be, in this case, it should be outside. It should be even with the else, not inside.
Gotcha.
In my opinion. Okay. Any other questions? Cool. All right, I'm going to share again. And let's go to Thawny. Okay, and then hang on a second. Okay, so you should be seeing Thawny, right? Oh, somebody say something.
Yeah, I can see it.
Well, when I ask, I need somebody to say yes, Doug. We see it. I can't see what you guys are seeing, okay? All right, so file, new program. And I'm just going to call it the, oops, I have to be able to type. I need a bigger workspace. Okay, and let's save it as this. Our file is about math tutor. .py. And then the date. Again, doesn't matter how you put it in. And author. Okay. So basically, we're going to have a math tutor. We're going to generate, at least at the beginning, we're going to generate two numbers. And the user is going to pick addition, subtraction, multiplication, or division. And we're going to keep it at the elementary level. In other words, we're not going to deal with fractions. And I'm going to show you how to do that so that we don't get fractional answers, okay? In other words, if we do if we tried to divide 3 into 10, you would get, I would ask you, what's the right answer? Is it 3? Is it 3.3? Is it 3.33? 3.33333, et cetera, et cetera. So which one is the right answer? So for right now, we're going to make it so you can never get a question like that. Okay. So we'll fix that. We're also not going to deal with negative numbers. So in our subtraction, we are going to ensure that you never get a negative answer. Also, of course, division by 0 is forbidden. So we'll worry about that also. Okay. So I'm going to show you, every time I take a break and you don't hear me talking, that's me drinking. And it's coffee. It's not any hard liquor at all. All right. So the first thing we're going to learn is import random. Okay. So that's going to be so I can create random numbers or pseudo random numbers. Okay. And then I got my keep going here. And again, if you got something else you'd like to use, I don't use continue because a lot of times that is a keyword. So if you're wondering why I don't have, you could have it exit and put a big N in there, and have while not, but then you got to use a while not or something like that. So I don't. All right. So now I'm going to show you something else. Oops, that's not what I want to show you. But while keep going. And then I'm going to say this. I'm going to say dot upper. Okay. So what I'm going to do is whatever they put in the future will be an upper. So we're going to make this an uppercase Y here. So no matter what I get here, back here, it'll change it to an uppercase character. Okay. So now I'm inside. I should be, oops, better do that, huh? So now I'm inside my main loop. Okay. Inside my main loop. And if we want at this point, we could go ahead and put in our keep going. So I could do my keep going here is equal to input. Move this over. All right. And then I'm going to come down here. My stuff's in the way here. I can't see. I hate when that happens. Okay, that should be okay. So now if I run this, okay, I said I was going to save it as Math Tutor. Oh, what did I do here? Input, oh, I forgot my parentheses. Okay. So I should be able to type a lowercase y, an uppercase Y keeps it going. Any other character quits. So that's what I wanted. Okay. So we have that again. As we build these, when you're doing your program, you know, it might seem silly to keep checking your program. You don't want to sit down and write a whole program and then run it and say, "Oh no, it doesn't run." I mean, that's just silly. You're just, you know, you're waiting, you're just setting yourself up for failure. Because very seldom will you sit and type a whole program out or think a whole program out at one time. So you need to get parts of it running. Okay. And then you check that part, get in, add some more. In fact, a lot of times when we build larger programs that span several days to write, what I recommend would be to you get it to a certain point. Let's say you're working on it today, you save it. Okay. It works up to today. Then tomorrow, I would copy what I did today, tomorrow morning, and then I would add to the copy. Okay. Leaving what I did the day before. Because sometimes what happens is we'll start working on something, add stuff to it, and then the whole thing goes to hell in a handbasket, right? At least we know up to the point of yes, so you're not going to lose your whole program, is what I'm going to tell you. You don't destroy the whole thing. You at least can just lose a couple hours worth of work versus all that you did before, if you know what I'm talking about here. It's always good to have a backup. Okay. So we have that. So now the first thing I think I'm going to do is I'm going to generate my numbers. So I'm just going to call them num1 is equal to a random. And random has a method that comes with it. And I just happen to know it's random integer. And I want numbers from 0 to, I think this will give me till 9. So maybe I'll put 11 in there. Okay. So that should give me numbers 0 through 10, I believe. And then number 2, same thing. And 0 through 11. Now, a thought, again, here's a thought. If I make number 2 between 1 and 11, I would never have to worry about division by 0. However, I want my students to know how to use 0 in addition, subtraction, and multiplication. So I'm going to make it 0, and then I'll deal with the problem, the division by 0 problem, when they do division. Okay. But I'm always thinking about the rules and how it's going to go. Which way would it be better? Okay. Which way would it be better? And so let's go ahead here and we're going to see if, in fact, these print out. So we can say num1, num2. Save it, run it. Run here. There you go, 6 and 1, 1 and 3. I'd really like to see if I get a, oh, look at how nice I spelled continue, right? I would like to see if I get a 10. There we go, there's a 10. So I'm pretty happy with that. I will change my continue here so that it reads all right. So there, we've checked that. We got to that point. Okay. And now I'm going to create my menu. And I like, for user friendliness, to have a banner. So I'm going to just say this is the Acme Math Tutor. And again, if you want to use different characters or whatever, you can actually use ASCII and make a whatever you want around it. And then we'll print. Okay. So I have an idea. I want to try and kick over. I'm going to put a /T for a tab in here. And then menu. And you'll see here, I'll run it real quick. And you can see menu gets kicked over about that far. So then we're going to say print /T. And this one is going to be addition. And then we'll do print /T subtraction. And we'll do print /T multiplication. And print /DT division. Okay. I think that looks good. And let's run that, see what it looks like. Oops, division, missing a double quote right there. Again, that's the thing about using an IDE instead of just typing this into a text editor, which you can, again, very easily do. It's just a text file. So you could go and you could type something into Notepad and then run it out of Python if you wanted to. The problem is that it's not going to show you your errors. So we pick an IDE, and that's an integrated development environment to help us program, okay? Because it finds the errors and yeah, we can fix them. And I'm missing, of course, a parentheses here. So I kind of like that. And then I'm going to come down and I'm going to have something called choice is going to be equal to an input of choose A, comma, S, comma, M, comma, D, or D. And then I will put a colon there, a space, parentheses, and that. Okay. And I'm going to come down below that and say choice. Now, this is just one way to do it. I could put it in the actual, but I just want to do it one time, so I'm going to do it this way. So choice is going to be choice upper. So in other words, no matter what if they type in a lowercase a, a lowercase s, a lowercase m, lowercase d, it's going to turn it into an uppercase. So I only have to worry about uppercases in my, so I'm going to type a lowercase a, and you can see it prints out an uppercase. Lowercase y, I can do a d, and it will still works, okay? So that works good. All right. So now I got my choice working here. And so now I've got all my input. Okay. So this up here is my input and my prompt, you know. So this will be my processing here. And it's going to be an if statement. So if choice is equal to the character A, then I want to print problem, space there, comma, num1. And you know, we could actually do our, let's see how this works. So we'll say problem, parentheses D, plus parentheses D, and then equals, then there, and then this, and I think we put in num1, num2. And let's see if that in fact works. It doesn't. Okay, type in what, keep going. So what am I missing here?
Oh, it's one more parentheses.
Oh, thank you. I should know that because it ran on. And so if I type an A here, and there you go. There's my problem printed out nice and clean using this print method. All right. So now I need to, whatever I'm generating here, if it's an addition, I need the answer. But I need the answer to be able to, I need to be able to get to it outside the if statement. Okay, so I'm going to go outside of my loop, even all the way up here to the top. And I'm going to create a variable called answer. And just put it up there. Oops, I don't need that in this language. And as long as I'm doing the computer's answer, I might as well do a user answer up here also. So I'll initialize that up here also. Because then I'm going to come back down and calculate the answer. So answer in the case of addition will be nothing more than num1 plus num2. Okay, you guys with me? And let's see again if it works. We'll test it here by just printing the answer. And we should get the right answer. Nine plus 8, 17. If I do a Y, check it again. 9 plus 0 is 9. So it looks like it's running fine, right? For addition anyway. Okay, so normally what we do here too, I kind of jumped the gun here, is we would have stubbed this in. So I'm going to finish stubbing it in. So I'm going to put my else if here. Normally what we do is we put like and then I can go back down here and do my else if. So we stub all these in right off the bat because then I could have tested to make sure my decisions are working correctly. Right off the bat. Oops. What did I do here? Oh no, I didn't what I want to do. So I'm going to do this. Okay. And then okay. So if I do that, how's that gonna? So if I do that, then it's going to keep going. Now that would work, except there's going to be one problem. So if I do an S, so subtraction is here. If I do an M, does that. If I do a D, does that. If I do an S, or no, an X, it comes out is here. Division is here. So it just quits. Oh, I did a D. Hang on. Yikes. X, trace back, Y.
Quit the program.
Yeah, but I got an error there too. Oh, I typed in an X. Why did it do that? Oh, because I had already quit the program. Duh. Thank you. My problem is that I was getting the answer, the user's answer. So I'm going to have to figure out something later on. I'll show you when we get there. Okay, so we got that, and they all work. Okay, and it's looping and blah, blah, blah. So now this one here is pretty much, I'm going to control C that, copy it, and paste it into multiply. Because they're pretty much the same thing. There's nothing I have to check for really. So we'll put an X there. Blah, 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 blah. The answer is just going to be changed to a splat. Uppercase 8. And now we can check that, make sure multiply works. If we type M, 2 times 3 is 6, so that works. Okay, so now we're ready to look at the subtract. So this is going to be here. Not too much difference. Be problem %d minus %d is equal to space. And the same thing we did up here. So that line is actually the same thing. Percent sign num1 comma num2. Extra parentheses there. Now, enter. Okay. So we're going to go ahead. Oops. Check. For negative. Or no, we'll just put this. Prevent negative numbers. And again, it's just what I'm doing because this is elementary, very, first grade. They haven't learned negative numbers yet. So we're going to put in this. So if num1 is less, num1 is less than num2, okay, then we're going to have something called temp is going to be equal to num1. And then num1, let's see, num1's going to be that. Oh yeah, then num answer will also be equal to num1. And you know what? I got to move these. So the answer will be equal to num1 is what I want. Or do I need that? Yeah, num1. And then,
Isn't it num1 equals num2?
yeah, that's what I was going to put. But I could still do it this. Hang on one second. I'm going to move this up on above this here first of all. So I'm going to control exit and move it up. And usually that's what I do. I usually just say it's num2. So here we got temp is equal to that. This will be num1 is the answer here. And then yeah, what am I thinking here? Num2 is, geez, Doug. Hang on a second. I'm thinking division already. So num2 is equal to num1. I got it backwards again. Num1 is equal to num2, and then num2 is equal to temp. There we go. So now you'll never have a negative number. Okay, it'll never come out. It could come out as 0, but you'll never get a negative number here. So here, our answer will be equal to num1 minus num2. And then we'll just, for now, print the answer. We won't want to leave that in once the program, once we are ready to run the program. And enter S. And you can see 8 minus 5 is equal to 3. I'll run it again. S. 2 minus 1 is 1. So it looks like it's working fine. Okay. So then, let's see what we got going. So I'm going to move this up a little bit. And drop down here to my division. Okay. So first things first is if num2 is equal to 0, okay, then num2 is equal to 1. And I'm missing an equal there. It should be this. So that fixes that gets that. Okay. Then the next thing I want to do is to prevent fraction answers. And to do that, I'm going to do let's see here. I'm going to do answer is equal to num1. And then once I get that number, I'm going to say num1 is equal to num1 times num2. Okay. And then I'm going to do the print thing. Oops, that ain't what I wanted to do, is it? %d divided by %d is equal to then percent num1 comma num2. All right, so what's going to happen here? We're going to save, we're going to get the answer right away. And so I know, let's say the number, let's say it's, it generates 3 and 9 or something. So the answer is going to be 3. Okay. Then what we're going to do is multiply the 3 times the 9 to get the real to 27. Now remember, we saved 3 up here. So now num1 is 27. So now my problem is 27 divided by 9. And my answer then will be the 3 that I have up here. And I can show you how that works. We'll just go ahead and print the answer here. So now if I pick D for division, I get 72 is divided by 8 is 9, and that's right. I'll never get a fraction. 8 divided by 4 is 2. Okay. And of course, I'll never get division by 0 either. Because number 2 will, if it generates a 0, I've taken care of that by making this a 1. So now we finished the computer part, right? Okay. And since I know it runs, I'm just going to go back and mark out all my answers here, because it's not much of a quizzer or that if we tell the kid what the answer is before they put their answer in. All right. So instead of putting in each one of them, I was right now where you ask the user to type in their answer, you would put it in each one of them. Okay. If I just put it out here, then even when they put in a mistake, it's going to ask them what their answer is, unless I do something, right? So I need an if statement here, it looks like. So I'm going to say if the choice is equal to A, or choice is equal to, and of course I got not enough equal signs. I hate when I do that. You'd think I'd be used to it by now. I write enough of these things. S or choice equals M, or choice is equal to D. Then what I want to do is have user answer be equal to an int input that says enter okay. And then I'm missing a. Again, if you notice, the IDE knows that something's wrong, because when I hit enter here, it doesn't take me back to the proper tab, right? So it knows I'm missing a parent here. Now it takes me back to the proper tab. So in here, I'm going to say if, you should be able to spell user answer, Doug. So if my user answer is equal to answer, then I would go ahead and print. For right now, we'll just say correct. And then we can do else here. Print wrong. And go ahead and save this thing.
Doug, you're gonna crush these little kids when they get the wrong answer.
I know. I used to write them. Oh God, I've had them where um, back in the day we'd write programs. I had a bunch of Southern Illinois University students, and we did a program where it was Hangman. Excuse me. So they played Hangman, and it was in Visual Basic, so you could do graphics, and we had it where it would like they had like a steam. I'm gonna sorry, um, like a steamroller, and would steamroll people and damn it, hang cats, and I'm sorry, but that's what they did. Blow stuff up, and yeah, yeah. Well, I got this is encouraging here. This one is wrong, right? Yeah. Study more.
Just
Uh,
call it operant conditioning, you know.
that's right. So we run it here and see what happens. So if I type an A, it says 4 plus 3, and I'll type 7. And it says my answer is correct. I hit Y. I'll do an S for sub. So 9 minus 0. I'm going to put in an 8. And it says it's wrong. Good for us. Now you can do an M for multiply. And 8 times 9 is 72. And that's correct. Hit a Y. And now my division. 88 divided by 11. How did I get an 11? So it must generate. Okay, so we need to make a change here. And that's right. And then N here. So we are generating, I guess this is a little different than, so this should be a 10 here because we don't want to generate in most languages, you don't generate the last number. It's always one less than that. But I guess Python, if you haven't know, one of the reasons people originally started doing Python was because they made it very simplistic, uh, or so they thought. Uh, and so some of the stuff, like you'll notice in our if state, we don't have to put parentheses around them. We're not putting semicolons at the end, which I kind of disagree with, because then you're really stuck on this, the indentation. And I mean, if it's off, it'll, I mean, it just won't run. It'll just say your indentation is off. Okay. So what I got now is the basic program. Okay. That we asked for. Now, would we like to make it better? Well, we could. Let's do this. Maybe what we would want to do is if that's that.
I mean, wouldn't you want to loop it so that if the user triggers the else statement, you don't have to then type Y as well?
Well, you could. And again, if you want to build that in, what he's saying here is, why do you go to the end of the program when they mistype here? So you could very well put a loop here and just take them back to
That'd be
here.
that'd be a do loop, right? Do those exist in Python?
No, you just use a while.
So it'd kind of be like while choice does not equal
Yep.
AM, S, or D.
Yep.
Print out,
Well,
an
let's
error
try.
correction
You want to
statement,
try it?
and then take user input once again to get a sentinel value.
Right. So
Right.
what I would want to do though is just display the whole menu again. So we could put another while here, and then we can say while choice. Now choice though is going to have to be declared. Let's do this first. Choice will be equal to how about a X, right? And then if I do while choice is not equal to a or choice not equal. I haven't thought this. You've taken me on to new territory here because I haven't checked this out yet as far as should I do it this way or choice not equal to M or choice is not equal to
Yeah. So this is kind of like what I was asking about earlier. So if you took that while loop you just wrote, right?
yeah.
You throw it under choice equals choice dot upper.
Okay.
Like if you threw it down there before you even access the processing. So if the user
you don't
does
have
not,
anywhere, it's just going to run on forever because you don't have a way
but then
to increment. The fourth part of the loop is to increment. So if you put it down here, you'll never get out.
but couldn't you reprompt with the menu?
No.
Yeah. Couldn't you put in the menu a queue for quit and then put the whole thing in a while loop, put one else if statement for a queue, and then it would loop. And then anytime you did a selection, if it was queue, then it would quit the.
If I do that, if I have another one that says quit, okay. So
I mean, that would, you would kind of have to take out the keep going thing or rethink
right.
it.
You would have to get rid of that. And then here, where's your, so it's just going to keep going until you put in a queue. So you could do that. Okay.
Right. But all I was saying was, so yeah, right there, line 31, throw that while loop on line 31.
Yeah.
Inside of it, print out like while it does not equal AS, M, or D, print out the Acme Math Tutor in the menu again and reprompt choice equals input again.
Well, but then you got repetitive code. What somebody else just said, who was the other person with the quit?
That was Nathan.
That was me.
Oh yeah, you could get rid of this while up here and make it a queue, I think, and add queue here for quit.
You do while not queue.
Right.
And then it would continue until.
While not queue, it would continue until so you could do that. Okay.
So what I said is repetitive, but would it work?
It would work, but you don't want to really have repetitive code.
Even in a validation loop?
Well,
I mean,
again, you already have it here once. Okay. So I would prefer the one where we would change this to where it's not queue and then put quit in here. So then if they didn't here, it would just loop back up to the top. Okay. And represent the menu again until you type queue.
So what you're saying is when you're prompted with the menu, if you didn't type Q, it would do what?
It would keep going. The only time it would quit was if you type a Q.
Right, but I'm not talking about quitting. I'm just talking about if you don't type anything or if you do type something
Right.
that's not ASMRD.
So what happens is you come down here, you typed in the letter X. All right. And what would happen then would be that it would come back up here and it would prompt you again for ASMD or Q. And then repeat this whole
There'd
thing.
also be, you'd have to put in one more else if statement, of course, for the Q.
Right. Yeah, there would be it. You'd have another one up here that said else if choice equals Q. But I'm just going to leave mine. If you guys.
Yeah, I guess I'm just trying to get to the root of just a simple while input validation loop because I can't find a straightforward answer on the internet. And like, at the beginning or before we started the demonstration, I was asking about it. I did it again. And it still didn't work even when I reprompted, for the user to enter a value that ends the while loop. So I was just, I don't know, I'm kind of a little bit lost right now as far as just simply if the user doesn't enter what you want, how do you just, I know how to prompt them again, but then it still doesn't just go past the loop.
Well, we can't hear you, Doug.
Doug, you're muted.
I know we can't hear him, but David, I think we'll probably cover functions later, but you could probably put that in a function and just call that function over and over again.
Right. And that would cover the repetitive code issue, but it's just like in levels of programs like this, I don't know why I'm so confused about just simply asking the user to enter ASMRD. Like, because in Java, you can put in an if statement or a while loop and it works. You say while the user does not, and while choice does not equal ASMRD, prompt, put the prompt in again, take the user input again. And then when that happens, it just moves forward to the next line. But I haven't gotten that to work in Python yet. So it's just, yeah. It was simple enough in Java is what I'm saying.
No, I hear you. I think it is here, but I think it's something small that we're both not seeing.
Yeah,
right
it's
now.
probably just some little detail. Yeah. And anything I look up on the internet is just one, overly complicated. Two, it involves techniques that we haven't learned yet, so we can't use them. So it's like,
Can you hear me now?
Yeah.
Yeah.
Sorry about that.
But yeah, I didn't mean to rock the boat. I'll just play around with it more.
No,
Yeah.
I mean, it's a good point. But there is a format I think we could add quit to here and then put all that in a loop where it's not just going to keep you inside. Well, because I mean, you need the menu to come back, because if you scroll down too far, you won't be able to remember what the menu is. So I always try to re-display the menu of where you're going to get your choices from. So
yeah, and I know in Java you did it with a do loop, and it's just
right.
really easy, But
Well, it's so easy in a Java is because we have has next.
Gotcha.
And we don't have that here. If again, for the people that don't know Java, there's a method that comes with the scanner that's how we get data in instead of input like you do here. that has a method that checks to see if the data type is correct, stuff like that. But also we can check for, but you're right. In this case, you're checking the loop. So it shouldn't really be a problem in reality. If you,
if the loop was set, I know we haven't covered Boolean stuff yet, but if like a do while is essentially checking for one condition.
right,
Yeah.
So
while true.
Right. So you could set a loop to true and then have something actively break out of it.
Right.
So like if Q is found, so an else if statement with Q, then it would break the while loop. But then anything outside of that, it would continue to loop through and give you your menu.
Yeah.
I think.
You're right.
Yeah, I can. Yeah, if you. Also, I didn't mean to interrupt the direction.
Oh, you're
of the class.
fine. You're fine.
But yeah, if you give me 30 seconds, I can show you exactly what I'm talking about too. It's just it's weird because when you reprompt for the Sentinel value, it still doesn't. Do you see what I'm saying at all, Doug?
I do. I understand what you're saying. So, but I'm just trying to think here if I want to take a look at that. What time do we got right now? Anybody got a?
It's 5:24, and no worries.
Okay. Well, so okay, let's leave it at this. Here's the basic program. Okay. Now, if you want to, I'm going to, again, since I haven't looked at this really except in this format here, we can go ahead and I'm going to go ahead and mess this up. Okay. So this solution here will get you your 10 points, but let's take a look at it. Okay. So if I put here, if I have this here, and then this here, keep going, is y. Okay, so while not equal to y, maybe. Let's see here, choice, okay. So if I add a choice here, of, and I just can't type today. Not that I can type any day. Okay, so we got that, and then we can get rid of that. Delete that, space there. And then if we put a Q in here, okay, so then we convert that to a Q. So now if it's A, we don't care. S, we don't care. Those all work. M, don't care. D, don't care. And then here. Because I don't think this should be this hard.
Well, also with Q, couldn't you just add an option to the else if, be else if choice equals Q, and then use like system.close or something?
You could. I try to stay away from system.close because that's kind of like an abnormal ending.
Ah, gotcha.
You know what I'm saying?
Not in
Couldn't you-
experience, but in theory, yes.
In a sense, that's my scenario. So now if I come down here, if choices to enter your answer. and then-
Since we're saying this, David, if you were to just, if choice was Q and you had that in the else if statement, wouldn't you be able to, at least this is what I was doing, just set keep going to choice and then immediately it would jump out, but otherwise it would hit the else statement and
Say again, man.
so since we're checking the value keep going,
Right.
once if we had another else if statement with choice equaling or
So-
checking for choice, you could just set keep going to choice, and now keep going would not be Y, and it would
Right.
jump.
So what he's saying here is if I make keep going equal to Q, that should wreck it, right?
Yeah, that should jump out of the loop.
And then do I still need, what's going to happen here though? Blah, 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 blah. I need this inside of there now though.
Why don't you test it?
I will. The keep going here, we don't need anymore. Right?
I think you. I mean, you do, right? For any other option
And,
besides
oh
Q.
yeah. Okay, let's just leave it there for now.
You could throw an iteration of that keep going equals input into each
Let's just see
option
what
in the
happens
if.
here. Okay, so it kicks me to there.
I think it's because it's going to call that after the menu anyways, which you're going to go to the top of.
Well,
Okay,
in if user
So, hang
equals
on a
answer, you can just throw keep.
that works. Okay, so that's 8. Okay, so now if I hit Y and I type in X, see, it's taking me down to the bottom again. Takes me back. But then if I hit Q, it's going to take me down. It doesn't do anything. So
So from what I can tell, you can kill the last choice input, and then
Right.
it will go back to the top, and you'll print the menu, and then you'll have your choice again.
But but then I also need to, this part right here, I need to move it somewhere. If you know what I'm saying. Or it's always going to
Want to still check that?
It will, but then
Why don't you put keep going in each of the if user equal underline 73, put keep going equals input, and then in the else put keep going equals input.
Yeah, I can see that. Putting it after the print.
Oh, I see what you're saying. So if I move,
So that will at least cover, if the user chooses, a math an option.
see, this would, if we had functions right now,
right.
it would work. We could just call it.
But we don't, Doug. We haven't learned that.
Okay, let's see what kind of damage we get now. So if I hit Q, it quits. That's a good thing.
This feels like trying to assemble a car engine with a little kid wrench.
So the addition works. And it says correct. And then if I do this, all others quit. Okay, so I type Y now. It comes back here. So if I do a B, it takes me back to my menu, and that's what we want. And this will be a 2, And that works, actually. So
I'm smart, Doug. No.
so our queue works here. And then we're getting our message here. And then if it's something else, it does the answer thing. And we jump back up to the outside loop up here. So we actually have, actually works pretty decent, to be honest.
That was a good thought experiment there.
Yeah. All right. So I'm going to stop sharing and stop